In the previous lesson, we spoke about combined probability using one dice or one die, and today we're going to use two dice. The other title in most textbooks on combined probability, they call it combined events. So, events, or what are the other terms for events? Happenings or an activity or occurrence is also a way of saying this topic is combined occurrences or combined happenings. So just to make it find a way to use different terminologies. So in the past lessons, I did talk about creating all possibilities using a dice or both dice or two coins or four coins. Today, we are going to list all those possibilities using what I call space diagram. Space diagram. And to do this, it's quite simple. You just have one die. Yeah, the first die, or we could have really a proper example. Let me just get my die. Okay, I got these two dice in here. There's the blue and the white die. And of course, you list all the possible occurrences. So with the blue die, you could have the results could be 1, 2, 3, 4, 5, and 6. And with the white die, the results could be 1, 2, 3, 4, 5, and 6. And all you really need to do is make a table. Similar to learning how to use the multiplication table when you were young. It's really similar. Okay, I hope I have enough space to do all of this, and I hope as I'm doing this, you're also doing it there. Okay, so then you look at all the occurrences. It could be a 1 and a 1, 1 and a 2, and you go fill this up all the way. Yeah, true. This, so it will be, this one would be 2 and a 1, would be 2 and a 2, and so on and so forth. And so here we have the last bit. If you haven't finished it, you could pause this video and try to finish it and wait for me, or we could just continue. So these are all what we call the theoretical probability. So you could call this a theoretical probability space diagram. And so you could ask the question here, or we could really start answering a few questions. We could ask something like, what's the probability that the answer, yeah, would have at least uh, two would appear. Yeah, at least two would appear. Yeah, two would appear, and you just basically count how many twos are there. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your answer here is 11 of how many possible answers? 36. So you could look at it that way. Another question would be, what is the possibility that there's a double? Yeah. So, what's the probability that it's a double? That means it's going to be double two. Yeah. It will be the probability that it's a double two. Yeah. Here we had one, two. That's wait. Where's the double here? One, two, three, four, five, six. So it's really 6 out of 36, and then you simplify this into 1 out of 6. So that's how you really would do this. This is key in getting all the possibilities through theoretical probability space diagram. Actually, I would really call this a theoretical possibility. Yeah, probably it's a more appropriate term, but textbooks would always say it's probability. But I would say this a theoretical possibility space diagram. And there's so many ways of really playing this kind of diagram. So in our next okay, I'll give you more homework. So here, what's the probability that at least a 6 would appear? Yeah, a 6. There's always a 6. Yeah, at least one of them would appear. And so that's our homework for today. And in the next one, we kind of do this in a we'll try to have another way of writing the this probability space diagram in a different way. So I'll see you in the next episode.